Every star in the universe can either be big or small because of a mutual source, nebulae. Nebulae are known to be diffuse matter of interstellar dust or gas. Not only can nebulae be made separately by one of these components, but they can actually be made both of interstellar elements. These nebulae are visible as luminous patches or areas of darkness, which really depends on the way the mass is absorbing or reflecting the incident radiation. Something that you should know is that nebulae are able to form because of extremely cold temperatures that would be below 0 degrees Fahrenheit. The next stage is the accretion disk. It's a spinning disk of gas and dust surrounding a celestial object with its very intense gravitational field. It has similar properties to that of a black hole. It has been stated that in the binary star systems, there is a gravitational attraction of a denser star can pull matter that belongs to another star right into the accretion disk with its own orbit as of now. All that's needed for the accretion disk will eventually transform into spirals and go straight into the attracting star and adds all of its properties to its mass. The volume of the gas in the accretion disks that have surrounded black holes becomes reduced. After it becomes heated, this gas is then sucked into the black hole. Now it sends out X-rays and other radiation that can supply all required evidence for the presence of the black hole. A rotating disk of dust and gas has surrounded the vast core of the maturing solar system. That would be known as the protoplanetary disk, also known as the third stage. It will turn up and mature into an orbiting celestial body. A fine example of one of these bodies would either be planets or asteroids. On to the fourth stage, known as the main sequence. It is a major group of stars that form an infinite diagonal line on the Hertzog-Russell diagram. This line also measures the luminosity and surface temperature, however. In this next stage, it's become a red giant. It is considered to have a low surface temperature. Its appearance gives off a reddish-orange hue. Red giants are not main sequence stars that are positioned in the upper right of the Hertzsprung-Russell diagram. These giants aren't known to be massive stars, but later in its expanded stages of reduced mass of main sequence stars, that has been exhausted of its own hydrogen in their core, merging the last of the hydrogen into helium into a luminous outer shell. Going beyond that stage, it becomes a planetary nebula. This very well known to be a nebula have fine similarities in that of the Ring Nebula. The temperature is immensely hot. It's also a bluish-white central star that has been surrounded by an enormous amount of expanding gas. At last, the planetary nebula's final point to the stage, it ejects its outer layers, expanding its spherical shell, exposing its core. In results, become a white dwarf. It is one of the large class of small, faint stars of enormous density. It's also a remnant of a star that has collapsed, having an extremely dense state with no empty space between its atoms. The result would create a neutron star or black hole. Now, if it becomes a neutron star or black hole, then it would eventually evolve into a black dwarf. It is a celestial object that remains after a white dwarf that had used up all of its fuel, has exhausted, required to cool in order to become a solid mass of extremely dense cold carbon. No black dwarf has ever been absorbed. Lastly comes the nova stage. It has become a variable star that transforms into an upheaval explosion. However, this only looks to be as a quick change, large increase in brightness resulting in decline over the months and years. Finally, now that we've determined each stage, we can now decipher the evolution of a one solar mass star on a Hertzsprung-Russell diagram as shown.